When a fluid flows through a pipe, the internal roughness of the pipe wall can create local eddy currents within the fluid, adding a resistance to flow of the fluid. The velocity profile in a pipe will show that the fluid elements in the center of the pipe will move at a higher speed than those closer to the wall. Therefore, friction will occur between layers within the fluid. This movement of fluid elements relative to each other is associated with the pressure drop, called frictional losses. Pipes with smooth walls such as glass, copper, brass, and polystyrene have only a small effect on the frictional resistance. Pipes with less smooth walls such as concrete, cast iron, and steel will create larger eddy currents which will sometimes have a significant effect on the frictional resistance. Rougher the inner wall of the pipe, more will be the pressure due to friction. This activity aims to measure the loss of head at different flow rates in pipes of different diameters and to determine the friction factor. Apparatus and supplies. For this experiment, we will be needing a pipe holder, a set of pipes. For this experiment, we will be using the 5mm and the 7mm pipe. The differential manometer will determine the difference in pressure and head between 2 points. Now we are ready to begin. First, we must set up the pipe holders. Make sure the screws are properly tightened to ensure that the apparatus does not fall apart during the experiment. Next, we must place the selected pipe on the pipe holder. This can either be the 5mm pipe or the 7mm pipe. Adjust the pipe holder so that the pipe fits perfectly. This will reduce the chance of leakage which may cause errors in computations. Be sure to tighten all the screws to prevent leakage. Connect the pipes to the hydraulics bench by using a series of tube connectors. It is very important to connect the tubes as tightly as possible to avoid unwanted outflow. Once the hydraulics bench is connected to the straight pipe, the differential manometer is then connected to the pipe on both ends. Again, it is very important to connect the tubes as tightly as possible. And now the setup is complete. The difference in pressure head is then recorded and the flow is regulated by turning the valve. Be sure that there are no air trapped in the tubes or pipes as this can lead to misreading of results. Once the desired pressure and head is achieved, it is time to collect water from the pipe. In this experiment, water is collected in a span of 10 seconds. A graduated cylinder can be used to read the volume more accurately. Once the first trial is completed, replace the pipe with the next pipe with different diameter for the second trial. Data and results. The table above shows the average discharge taken from the volume of water obtained within a span of more or less 10 seconds for each trial on different diameters of each pipe. While this table below shows the pressure head difference and the frictional losses. Formulas and computations. The discharge is taken using the formula Q equals V over T, where V is the volume in meter cube and T is the time in seconds. The frictional loss is taken using the formula F is equal to 2GDHF all over LV squared, where G is the gravity of 9.81 meters per second squared, D is the diameter of the pipe in meters, HF is the difference of the two pressure heads, L is the length of the pipe, and V is the velocity taken using the formula V is equal to Q over A, where A is the area obtained using the formula A is equal to pi over 4 multiplied by the diameter squared. Sources of error. The sources of error may come from the incorrect measuring of the volume of water and inaccuracy of measuring the time. Carelessness in using the apparatuses can also be the source of errors in performing the experiment. Conclusions and remarks. In this experiment, our group has determined the head losses and the friction factors in different diameters, and in each trials we performed, there are minimal differences in the results. Therefore, we can say that we have performed the experiment successfully. Thank you for watching.